Bryan. Is Bryan with us? Bryan from Acala Network.
Hello, everyone.
Hey, Bryan. Good to see you. So you
Good to
ready
see you.
are you ready to get on with automatic schedulers?
Yep,
All right, cool. Floor is yours.
thanks. Hi, everyone. So this is Bryan from the Akala. So today I'm going to present you how to build a DApp using within the Akala EVM, and we're going to show you the on-chain scheduler feature they have implemented in the Akala EVM. So let's get started. So firstly, we had a crowdcast about talking about the ETHDenver event, the bounties, and more details. So you can also check out our crowdcast or our YouTube for more details. So a quick intro of Akala. So we are a DeFi hub of Polkadot. So we're going to be a Polkadot power chain offering become a DeFi platform. So we have built a few primitive services, which including a stablecoin protocol, a staking liquidity protocol, as well as a decentralized exchange and AMM style exchange. And we also have obviously other things like governments and the EVM platform as well. So we have the testnet live, so you can just try things there. That architecture is basically we're built on top of Polkadot. So Polkadot offers the shared security and all the cross-chain messaging stuff, and as well as all the other bridgings and other ecosystem. And we have built a various of DeFi primitive protocols. And one of it is the smart contract platform, the EVM platform. And then the developers, the DeFi other Solidarity developers will be able to deploy your Solidarity projects into the Akala EVM and leveraging all of the DeFi primitive that we have provided to the Akala EVM. So just another thing, Akala EVM, we're not trying to be 100 compatible with Ethereum because obviously there are already quite a few Ethereum layer 2 solutions or other smart contract platforms that are 100% compatible with Ethereum. So we figure there's no need to have another one. So instead of trying to build another Ethereum node to make our blockchain node become an Ethereum node, we do something else different. We developed JS and SDK. We call it Bounties. So that is basically taking the Polkadot extension, wrap it, make it looks like Web3 provider. So your existing Ethers.js script or apps will be able to use the Bounties and will be able to use the Polkadot extension for the signing and other stuff. And then our Bounties underlying the hood is using the Polkadot.js to talk with our blockchain nodes and some other servers. For example, we have indexes to query historical events, etc. So this allows us to do enable some quite unique UX and enable a few special features that cannot be done otherwise. So for the bounties, we have 2 bounties. Again, all these things we have talked in the crowdcast before, but just quick recap. So the first one is basically build a DApp and get and deploy in the Akala EVM. Should be fairly simple. And the second one is I would like to use the on-chain scheduler feature. So that is the unique feature of the Akala EVM. Hopefully this can solve a lot of troubles that cannot be, will be very hard to done in other Ethereum compatible platforms. So we have provided a hacker guide. So it's in our wiki page. So they should have all the resource documents, etc. that you need to down your bounty. We also please join the ETHDenver Discord. If you have any questions, feel free to ask in the Akala channels, and we'll be providing help there. Well, then let's start hacking. So before start hacking, just show you some of the tools and things they will support. So as I have mentioned before, we are not trying to be 100% Ethereum compatible. So we don't right now support all your existing Ethereum development tools, but we do support Waffle and Remix. So hopefully this should cover a big chunk of the projects out there. And we also have the EVM playground. So that is a simple UI I'm going to show you soon. So you can upload your contracts and call your contracts there, connecting to our public testnet or connecting to your local testnet. So that's just another command to help you to run the node. So you can either just build from the source code, run a Akala node from the source code, or you can just run with a Docker image. And we have also examples in the Akala EVM examples GitHub repo, so which should have all the code I'm going to show you today. So another few things. So Akala EVM, we have a few unique features. So first thing is we're trying to inherit all the goodness from Ethereum, while the community, the developers, the existing libraries, and the ecosystem. But Ethereum is an old project, in the blockchain time. So you have a few legacy decisions, so we have to want to avoid those things as well. But if we're trying to become 100% compatible with Ethereum, that means we need to inherit all the legacy decisions from there. Like for example, if Ethereum have a bug, then to be 100% compatible, we need to have exactly the same bug to not break smart contracts, which is not a nice thing for a new blockchain platform. So one example would be gas tokens. Some people say it's feature, some people say it's bug, but it's not a good thing for the whole thing in the end. So it's not something we would like to make it possible on Akala EVM. And so to highlight a few unique features of Akala EVM, so here we have mirror token scheduler. We also have Oracle Gateway. So those are the things we have implemented and ready to try in our testnet. And in the future, we'll also implement a lot more APIs. So we'll have some APIs for the cross-chain integrations. So you'll be able to send your tokens to other parachains of the Polkadot, or you can even send integrate with dots on the Polkadot. I'm also going to provide a lot more the runtime API of Akala. So for example, we're going to provide the staking protocol, the staking director protocol. We're going to offer the APIs of the stablecoin protocol as well. So those are still work in progress. So hopefully will be available soon. So let me talk more about the mirror token. So mirror token is somewhat similar to the wrap token. So on Ethereum, you probably already used wrap ETH before, but to make wrap ETH, you need to wrap it, mint it, and then to convert it back to ETH, you need to redeem it. But the mirror token, there's no wrapping required. All the native tokens of Akala will be exposed to EVM as ERC20, and they are sharing the same underlying storage. So if anything change on the balance of the account of the native balance, the change will be reflected on the ERC20 token representation immediately as well. So let me just show you, take a quick demo. So this is Akala EVM. So currently connecting to our testnet. So we have a few smart contracts. So those are the building smart contracts. So you can see we have our native token, which will be the ETH thing in our platform. So we have a few bunch more other tokens, which are our native tokens, and as well as a few cross-chain tokens as well. Like DOT will be the cross-chain DOT, and XBTC will be cross-chain BTC or the REM BTC. So so this is a native Akala is a native token. Let me take the DOT as example, would be better. So I can, for example, just query the balance of this test account. So I have this many dots, and if I connecting to the public testnet, and I can query the balance. So this is the Akala console. So it's the development tool for the Polkadot or Substrate projects. So if you only deal with the EVM platform, you probably doesn't need to use this one at all. But let me see extension. So I want to check my balance. So you can see all of my balance here. So the SAE just means there's a unit is with 18 decimals. So you can see the balance of dot matched to here. And then I can just try to make a transfer. I need to find the address to transfer. So let me find another account. Oops. Let me just do that this way. So this is binding the EVM account, because Akala is built with substrate. So every substrate address will have needs to bind the EVM account, because the substrate address is using a different account format with EVM. So in order to make sure like the substrate account can be used to sign EVM transaction, we need to do this account binding. So that's how you how to bind them together. So then I can send some dots to this account just using the transfer. Just enter some value, sign the transaction. So this is done. Let me check the balance again. Oh, the value I entered is way too small. So let me make a slightly larger number. So it, oops, wrong one. Yeah, so you can see the dot balance change here. So EVM transaction making the dot balance changes here. So go back to the next feature. So those are the smart contract address of the mirror token of the native token. So because they are the system smart contracts, so we can pick the address. So there's also another benefit is by looking at the address itself, you will know they are the official smart contract address. They are not just some other people deploy some other tokens name, take a name of the USD, for example. So next feature I would like to highlight is the scheduler. So let's allow the smart contracts to schedule a call after a number of blocks. So basically, let's say I want to say pay someone every month. Then I can just write a smart contract schedule call and make a payments from my account every month, or from the smart contract every month. So there's no need to have run some off-chain server or have some keepers sending a transaction to trigger the transaction sending things on the blockchain every month. So this saves a lot of things, make a lot of things much easier. There's no need to run so many off-chain servers. And the fees for the upcoming calls are reserved upfront. And then when the scheduled call get called, the fee will be consumed. And of course, the remaining one will be refunded after the call. So this is the smart contract address for the scheduler. Again, this is a system contract, so you can just looking at how many zeros earlier. So this is the interface. So let me just bring up the code. So yeah, so this is the larger. Yeah, so this is a scheduler. So it's very easy to use. Basically, just pass the contract address, the address that you want to be called in the future. The value, that's basically how much native token you want to send along with the call. And the gas limit, and there's also a storage limit. So this is a also unique thing of Akala EVM. So we have implemented storage rent. This is not enabled on the testnet currently, so you can just pass a large number. But later, when the storage rent is enabled, this can limit how much additional storage usage can be used in the call. There's a minimum number of delay, so for the call to be called in the future. So just one small thing. So this one is so if you're passing 0, this means the call will be scheduled in the next block. So if you're passing 1, the call will be scheduled in the 2 blocks after the current block. This is also not guaranteed to be executed, of course, because otherwise people can potentially schedule way too much call in a same block. So there's only a certain amount of blocks space is reserved for the scheduled call. And if there are too many scheduled calls, then they will be delayed to the later block. In future, we're also going to implement some auction mechanisms, allow people to bid for the executions to simulate some kind of like gas price bidding. So if you want to make sure your call gets scheduled on time, then you need to pay more money. But otherwise, you can just pay as low as possible. So the call is only get called when the blockchain itself is have a lot of free spaces. And then you pass the input data. So that's basically the selectors, the arguments, etc. And it will return the task ID. So this basically the block, the schedule will be called and the ID. So in the future, we'll also provide APIs to cancel or reschedule a scheduled task using this task ID. So this is the code to use the schedule. So there are two ways to invoke. So this is one way. So basically you have a constructor taking bunch parameters. So this implement the recurring payment. So let's say I have 10 native tokens. I want to do some budgeting things. I don't want myself can spend all of them on the day one. So I can set the smart contracts set the period to be 10. The period to be 1 day. What's the number of blocks? The count will be 10. Amount will be 10. Amount will be 1. So the payable will be myself, and then send 10 native tokens along with constructor. This will basically then the smart contract will pay me 1 tokens every day. So then to use the schedule is very easy. So just passing the address, passing the pay. So we'll be using this to pay back. The value is actually 0 here. And this is a gas limit, a storage limit, the period. So the schedule feature is only support one schedule, like one-time task. So you need for the recurring calls, you'll need to just reschedule it again in the next one. So save all the parameter to the storage, and after the period, so this pay called. You want to make sure other people cannot just trigger this maliciously. So you can just ensure the sender is from the smart contract itself. And then you can just transfer the token, reduce the remaining count, and schedule another one. Or if it's the last one, then you can be a nice citizen to free up this no longer useful smart contract, just self-destruct, who also at the same time send all the remaining tokens to the two destination. So this is basically how to use a scheduler. So it should be very easy. So this is another example. So instead of dealing with the native token, this is using the ERC20 token. So this is also I make it a slightly different format than the other one. So basically, I can deploy this token and make a scheduler service, and everyone can use the smart contract to do the recurring payments for any ERC20. So you'll notice all the parameters encode with the input data instead of the storage of the smart contract. So everyone can use the same recurring payment. So just run this. I'm going to use the UI, the EVM playground for this. So this is a command to start the testnet. So I can make this connecting to the local testnet. Local node. So first I can upload the smart contract. Oh, sorry. First I will need to build the smart contract, upload the JSON file built from Waffle. So it's just a pretty standard API file. So I already have uploaded here. So I can just deploy it. I will need to use the building div account, which is account that actually has money. So the block time is 4 seconds, so hopefully it should be executed soonish. Yep, so it's deployed now. So I need to take the smart contract address. I need to approve it so you can take my money. So I'm taking the dog as example. So I'm going to approve this account with just get a few more zeros. So this is now approved. So go back to the requirement payment. So I can use the schedule. So I would like to schedule the transfer of dots. Make every 4 blocks. So I pass 3 by schedule for every 4 blocks here. The count will be, let's do 5 times. The amount will be, so that should be 1 dot. I don't know, just make it to myself. So I can execute. So you can see now this is scheduled. And go back to the blockchain explorer here. You can I can see all the events here. So 28. So I think that's already scheduled a task. Yeah, you can see on the block 28 that is a scheduled task. Scheduled event on the block 32. There's no smart contracts call here. There's no one triggering the thing, but the blockchain itself is get triggered with the by the scheduler. So you can see there's a dot transfer from the smart contract to Alice with 1 dot, and there's also the EVM transfer events, which is slightly harder to decode. So there's also scheduled event. Yeah, so this is basically the scheduler is running and sending funds every 4 blocks. So let's say 36, there's some schedule, and at block 40, there's another schedule. So next one is block 44. So next one is 48, you can see here. Yeah, so this is basically scheduler running in action. So yeah, so with this, we can implement a lot of interesting things like this. You can just, for example, every month taking some chunk of the staking reward, liquidate them, or you can just, another common investment strategy is total cost averaging. So you can just deposit, or you don't even need to deposit anything upfront. You can just deploy a smart contract, just using the DEX to buy certain amount of dots every month or so. You don't need to have all the money available upfront. It will just try to buy it every month. So you just have your salary deposit your smart contract, something like this. So yeah, so this is basically how to use the scheduler. So next one. So next feature of Akala is the Oracle Gateway. So this allows smart contracts to access the price data from the Akala Oracle Gateway. So we have built a stablecoin protocol, so itself will need some Oracle data, will need some pricing data from the oracles. So we don't build Oracle ourselves. So we are working with different Oracle providers, for example, such as Chainlink, the BAN protocol, and a few others as well. So they will be feeding the price data for DOTs, BTC, and other coins into the Akala platform. But that just means, so this means we will have some high quality price data, so we can make them available to everyone, to all the developers as well. So that's why we implement this Oracle API. So you can just, very simple, it just, this is the contract address, and just call this get price on this contract address, and you can get the Oracle price. Then later we'll provide a bit more detailed API, so you can get, for example, the price for a particular Oracle provider. So for example, if you only want to use Chainlink, you can do so. Just get only the price from the Chainlink. So just to show you the Oracle. So this is the Oracle smart contract. So I'm currently connecting to our public testnet. So we do actually have the Oracle running. So of course, so I can just get price for the dot. So you can see, so dot price is currently $20-ish. So that's the timestamp. So this shows you when the last update price feed is coming. so you can decide if this is data is recent enough. And I can also query, I think 3 will be Bitcoin. Yeah, so this is the Bitcoin price. Seems like all-time high, not sure. Yeah, so this is how easy to use the Oracle Gateway. Yeah, so those are the unique features of Akala EVM. So we also have a few more other features will be available soon, or they have implemented, but we have disabled them in the testnet to keep the capability by later when we. So one thing is the state rent. So on Ethereum, we have the storage is huge. We have a lot of issues like the smart contracts just deployed. No one actually free up the smart contracts because why bother? But there's no one actually deletes the no longer useful data from a smart contract. So this is fine it's nice and easy for the developers, but it's causing a lot of increase the storage usage and increase the cost of the node providers and of the infrastructures. So we'd like to solve that. So we have to implement a very simple version of the state rate mechanism. So the smart contract developers will need to consider how much storage they use. They need to make sure they don't write too many data, or they need to pay for the data they have used. They have the incentive to free up the unused data or destroy the smart contracts when it's no longer used. But of course, this will come with capability issues when we enable state renting, because your smart contracts will need to have some money, might need to have some money to in order to call some other calls. Another issue of the Ethereum is the DApp account. So we have so many accounts that only have a tiny bit of Ether. That's just impossible to spend, especially given the current gas price. It just doesn't make sense to spend money on those accounts. So the account will just sit there, does nothing, use the storage forever. So that doesn't make sense. So that's why we have the extension deposit feature. So this is not actually we implement this feature. This is the Polkadot or the structure implement this feature, but we make them available to the Akala EVM as well. So all of the native tokens, the ACA token, dots, question tokens, etc., they have extension deposit. So if the balance drop below the certain threshold, the balance will be wiped. The dust will be sent to treasury. So this is just another unexpected thing for the smart contracts. So when you're writing smart contracts, there's something, if you want to deploy on Akala EVM, this is something needs to be worried about. But this is not enabled for the public testnet, so you don't have to worry about for now. Another feature we have is the deployment pipeline. So this will allow, so right now on Ethereum, many people just kind of test on production, deploy the smart contract, then it's public for everyone to use and see if it works. If it works, announce it. But this sometimes comes with issues that you don't really want people to try your unordered, unfinished smart contract. But you probably don't want to implement some permission control thing just make sure people cannot try your smart contract before you. So that's what we have to implement. So we have to implement some features. The smart contract by default, when deployed, they will be in kind of private state. So only a small set of people will be able to interact with smart contracts and to do some beta testing, basically. And when it's ready, then you can make it public and open for business, and everyone can start using your smart contract. So it's something similar to a test fly if you are iOS developer. And also during the private phase, you can also upgrade the code of your smart contracts. You don't actually need to implement all the complicated migration upgradability things. You can just using the native feature of Akala EVM to upgrade the code of the smart contracts. But of course, when you make it public, everything will become immutable again. So you can no longer modify the smart contracts without people notice it. Well, you just cannot no longer modify the smart contracts. So those are all the unique features of the Akala EVM. So yeah, seems like we are almost up to time. So thank you. Not sure if anyone have any questions. So
Bryan, that was awesome. Thank you very much.
Thanks.
Yeah, it's cool to see what's becoming possible now with a lot of these new blockchains like Polkadot, Cosmos. It's going to get really interesting here soon. So yeah, if you have questions for Bryan, jump in there. I'm sure he'll be eager to answer any queries you have. And thanks again.